right. Good morning, everyone. So I'm Mihir Somalwar from a company called Hensel Phelps. We are a large general contractor based out of the US. And then Diverge is the corporate venture capital and innovation arm of Hensel Phelps. Let's see. So a bit about Hensel Phelps. We're about approximately $9 billion GC, one of the top 10 in the US. We have 9 regional offices across the US. And we do a lot of projects across the US. So on an average, we do approximately 200 projects, ranging from aviation to hospitality, hospitals, data centers. We are, in fact, the largest aviation contractor. These are some of the kind of notable projects, for example, the SFO airport. But more than 60-70% of our portfolio is airports. So we do build a lot of airports. And then, as I said, Diverge is the innovation and CVC arm of Hensel Phelps. So our goal is to put a strategy behind how do we bring in new innovation and technology to the company. So just a bit background on me. I have a master's in robotics. From there, I went to Tesla. And after that, I went to a company called Safe AI. Cynthia from Safe AI is also here. I was a senior robotics engineer at Safe AI. And then I joined Hensel Phelps, and they tasked me to bring new robotics into construction. So really being fortunate at this company to work with all different sorts of robotics. Whenever there is a robotic solution deployed on any of our job sites, I'll go to the job site, I'll collect the data, and then create reports, and then share it with the enterprise. So that if a new project says, hey, Mihir, I want to deploy this robot, how does it work? I can give them the kind of the compiled feedback of how it works. So just as an example, you can see in this picture, we have the JBot, we have the SitePrint, the Civ Robotics, Spot, there's Tomorrow from Japan, some reality capture solutions, and then UCR, it's a humanoid robot company. Just a sample of some of the robotic solutions that we are deploying. And so we are officially launching our innovation center in September, but we have about a 30,000 square feet facility in Phoenix, Arizona. This is where we partner with universities, startups, and the industry to bring their solution in and test it before we deploy it on the job site. Because if it's a new solution, then deploying it directly on a job site can be risky. So we build a mock-up of a job site at the innovation center. We test it here, and we provide that confidence to a project management that it's working perfectly. We iron out the kinks, create reports, and once the projects get the confidence, then we go and deploy it on the job site. So in this picture, you can see we had demonstrations with the Hilti JBot. Tomorrow, we had a few universities visit as well. That's the Arizona State University that I'm giving them a demonstration. We have the Trimble Site Vision that they're seeing. Some of the HP SitePrint you're seeing on the bottom. And we also have a 3D printing group that builds model of 3D print. So that's in the center bottom. So in this quick lightning talk, what I'll focus on is from a GC perspective. These are some of the robots that we deployed: layout, rebar, drilling, reality capture robots like the Spot, and humanoid robots. Not deployed it, but we're testing it, and then go through some of the advantages and the challenges that we've seen. So first on the layout robotics, quick stats. So we've printed more than 2 million square feet till now. We are one of the first adopters of this layout robotics, and we've tested all of them: Dusty, Rugged, SitePrint. The advantages, as they mentioned in the previous call, improve accuracy, consistency, safety. You can print more information. Traditionally, with your chalk work, you're only kind of snapping lines. But with these robots, you can print anything you want. You feed it a smiley face, it will print a smiley face. So text, symbols, rich, dense information. You can also print, of course, you print all trades at once. So you coordinate with your trades, your mechanical, electrical, plumbing, you get everyone's drawing, you compile it, you clean the drawing, and you feed it to the robot. And all of the trades get printed at once. Compare that to the traditional method where each trade goes in, does their layout, installs it, and then the next trade comes in. That saves a lot of time. And of course, reduce rework, because if you're printing all of the trades at once, now you can walk the field with your trades. you can see, hey, there's my framing's going to go there, and that's my electrical junction box at the same location. So before installation, you understand where the clashes can be, and you can fix that. So less rework. Challenges needs accurate site control. It's not so much a kind of a challenge for the robot. It's kind of indirectly because you're using a total station. So a total station needs accurate control. If your control points are off, your total station resection is going to be off, and the total station is going to report the inaccurate location to the robot, and it's going to print inaccurately. So you have to have very accurate control. Line of sight, as was discussed as well, you need that constant line of sight. If you have a lot of columns, beams, sometimes equipment on your job site, you need to make sure it's clean and you have site ready and prepared for your layout robots. And needs pre-planning and document cleanup. So whatever you feed to the robot, it's going to print. It doesn't understand what's a wall, what's a frame. If you have a lot of garbage in, garbage out, if a lot of things in your CAD file that shouldn't be printed, it's still going to print that. So there needs to be that kind of preparation and cleanup, for which you might need your VDC in-house teams. Next one is a rebarting robot. So this is a robot from Japan, Tomorrow, that we've been testing. Advantages, traditionally you have these rod busters that manually tie, hundreds of ties in a day with their bare hands, and creates a lot of musculoskeletal injuries. It's actually one of the highest causes of injuries, wrist injuries. And of course, there are labor shortages as well. So all those advantages are taken care of by this robot. But the challenge is that the rebar needs to be laid without gaps. So there are some best practices. Think of it like a train on tracks. And if there are large gaps between two rebar, it's going to derail. Similarly, if your tracks are not perfectly parallel, if your rebar is not parallel, it's skewed, then it's going to derail again. And the other thing you have to consider is your supports. You can't place the supports at the intersection, because when the rebar gun goes down, it's going to interfere with that. So I have a video. Let's see if I can play the video. Maybe something is going on with the conversion here, but you can see the video online. Basically, it shows the rebar gun going down, and will show you that if there is a support in the intersection, then it prevents it from activating the rebar gun. Next is the drilling robot, the J-bot. Typically your trades can maybe drill 200, 300 holes in a day, but they have to carry these heavy drilling guns, climb up on a ladder. And I was talking to this tradesperson, and he's like, I wish we had the J-bot, because my chiropractor, he's so mad at me because a lot of shoulder injuries. And he's like, can you please get the J-bot here? So a J-bot is basically an extension, kind of, you can think of a human arm, and it's semi-autonomous. It's not fully autonomous in the sense that you have to manually drive it to a location, and then it has a 6 feet robot arm radius. And within that 6 feet, it'll drill autonomously all the holes that you've provided. Now, it has some of the same limitations that you've seen with, for example, site print, because it also relies on the total station for your accuracy. So if you do need line of sight, and again, if your control is off, then your drilling is going to be off. We wish it was a bit more kind of portable and lighter in weight and size, a bit more compact, so you can easily transfer it to a job site. Because right now it has to go in its box, it has to be shipped. So there's some kind of restrictions on the transportation. And of course, there's also this ceiling restriction for data centers. For example, we have ceilings that are very high ceilings, 20, 30 feet. This has a high limitation of, I believe it's 16 feet. So the best practices, you do need pre-planning. pre-planning with your trades, because let's say the JBot is drilling holes for mechanical, electrical, plumbing, all of the trades. And let's say your mechanical trade is operating the robot. He or she needs to understand that if a hole needs to be shifted for some reason, in what direction should it be shifted, by how much. So they should have this kind of pre-planning session with all the trades, asking them if this hole needs to be shifted, what's the plan around that? So coordination with the trades. Next one, so this is a company called Track 3D. Other companies in the space are Open Space, Structure Insight. You might have heard of them, Drone Deploy. Think of it like Google Maps, Google Street View, but for the job site. So what you do is you go around with this 360 camera, you walk the job site, and it creates this photo documentation for the job site. So you can have your 360 photos on the left side. You can compare them with your BIM model on the right, and you can see the progress as the job site progresses. Let's see if this video plays. Not quite. So what this video supposed to show is, let's see. So what you can also do now is Track 3D uses AI to analyze what has been installed on job site. So for example, it can detect walls, your framing, your paint of code. So using segmentation, it analyzes what has been installed. And once you know what has been installed and how much of that has been installed, you can get your progress reports. So for example, for a job site, as an example, you see the top track, bottom track, framing, and the percent complete that each kind of those components are achieved. And of course, you can also get trend charts. So this really helps superintendents to allocate resources. If you see some area lacking, you can kind of allocate those resources towards those areas. So this is Track 3D. As you saw today, it's done with humans. They go around with cameras on the job site. It takes a lot of time. So of course, the next logical solution is, why not use robots? So robots are faster, it's safer, it's repeatable, because for each job site walk, you have to ensure you're walking the same route so that you can compare side by side the photos throughout the different dates. And robots can really guarantee that. But what are the limitations? With the Spot specifically, there is a height limitation. You can't really capture above the ceilings. There is a limitation on the height. Indoor navigation, we've seen the biggest challenge with Spot is the construction space is dynamic. It's constantly changing. You deploy the robot today, you map your environment. Tomorrow they install drywall, they install framing. It looks totally different and the robot gets lost. It says, I haven't seen this before. So what you can see here is kind of the slam that happens indoors. This works in static environments. It's good for oil and gas and manufacturing. When it comes to job site, it's so dynamic that robots gets lost. And I'm seeing kind of outside some of the posters, some of the teams addressing this challenge of dynamically changing environment. So that's a great thing we're seeing. And the other thing is right-of-way rules. So this is an important one. We were deploying this robot on an airport, and it's a busy site. You have your tugways carrying your baggage. Spot doesn't only have to detect that it's an obstacle, but it also has to understand this is an intersection. I have to let the vehicle pass before I can move on. So that's something it still doesn't have. So that's on quadruped robots for reality capture. The next one is humanoids. So some of the kind of challenges with Spot can be alleviated with humanoid robots because it's the same human form factor. Wherever humans can go, your humanoid robot will be able to go. Can capture from a human eye level. It can open doors and take elevators. Now you can mount your kind of arm on the Spot, but that will interfere with your sensor and the field of view. So this, I think, is the best form factor for capturing. So we're working with a company called UCR, Under Control Robotics. It's a startup from the Bay Area. We're working with them to see how we can kind of solve some of these challenges. And we've identified some of these short, mid, and long-term goals for them. The short-term goal is this reality capture with 360 cameras. That's a low-hanging fruit. Once it understands how to navigate the job site and maybe manipulate a few objects, the midterm goal would be lightweight tool handling. Say you have your worker on the forklift or on a scissor lift. The worker might say to a robot, hey, grab that piece of equipment, and the robot should be able to go and get that equipment to that worker. And then long term, once you have these advancements in AI, dexterity of the robots, and environmental robustness, then we can start looking at component installation. For example, installing drywall, framing, and then kind of a flexible labor support. So that's long term. I think that's going to be at least 5+ years. So what are some of the challenges? Typical job site, not our job site, some competitors' job site. It's pretty cluttered. But it's unstructured, it's constantly changing, and it's pretty cluttered. So today, robots, they can see it's cluttered, but if they start walking and let's say, there's electrical wires, there's caution tapes, and it wraps around their legs, they can't really identify it. If it's dragging a lot, maybe there are sensors, the torque sensors can maybe, detect that there is something dragging it. And today we are seeing research where robots can adjust to different site conditions. For example, if it's on snow, versus dirt, it can change kind of the torque performance. So it can still traverse in that region. But still the problem is, it's not about understanding how to just the locomotion, but understanding that something is around its legs and looking down and then kind of detangling whatever it is, because that can cause hazards if you're dragging tape and electrical wires across job sites. What's the cause of that? It's limited perception. Today, you have robots that mainly have a front focusing camera. So can you have a camera that kind of sees down as well, maybe behind as well? And lack of physical feedback. A lot of sensors today are focused on kind of the hand and the feet, but nothing kind of around your joints and legs that can detect that there's something there stuck there. So in conclusion, robots are here to stay. We are working with a number of startups at the Innovation Center, partnering with them, testing their robots, showcasing them to our projects, to our clients. So if you have a robotic solution, if you'd like to test in a real job site environment, come to me, and then we can find opportunities to test your robot on an active job site as well. And then shout out to CRC. CRC is Construction Robotics Coalition. We are a group of kind of robotic leads and CEOs and VCs from different industries. And then we come together, discuss what robots have you deployed, what have we deployed, what are some of the best practices. So Henning, Victor, they're both from CRC. So feel free to reach out to them as well. Perfect. And I think we'll take questions at the end, right? Yes. Awesome. Thank you.